Okay, so in the last video we were looking at the height function, trying to build the height function from page 86, and we saw that it ran into a little bit of trouble. There was some infinite loop stuff happening. So I wanted to just back up a little bit and take a look at Hailstone, the original Hailstone 83 from page 83, and also the path length function, which is, where is that? That's on page 85. So these are both defined along with the even p. These are all defined in the chapter 4.py function. So here's Hailstone and here's path length from page 85. Okay. I have Hailstone on here just for illustration purposes. I'm not actually going to use it when I run this, but I just want to show how I got from Hailstone to path length. Okay. So in Hailstone we have this one input n, and we keep recurring through until we get down to n equals 1, right? We have to eventually get down to n equals 1. Or that's the conjecture that we always will, right? In path length, what we want is we don't want to get here we're looking to return some final value for Hailstone, right? With path length, what we want as the final return value is the actual length of the path. Okay. Not the value that we end up with. So in path length, what I do is I set myself up here with this, like, make this little helper function, this PL, this function PL here, that has two inputs. It has n, and this is basically where it gets started off, and then there's recursion that happens once you get into PL. But to start it off, there's this n comma 1. Okay, so it starts off with effectively with a length of 1, right? Notice if the initial input to Hailstone is 1, then it returns something right away. It returns a 1 right away. So there's only going to be one element in the path, and that's just going to be the number 1. So it's safe to say that if I said, you know, n comma 1, if n is 1, then the length of the whole thing is just going to be 1. So I can just return length, which in this case will be this 1, right? Then what I'm doing is I'm doing the same test that I do here. So notice my tests are the same. I have if n equals 1, if n equals 1, right? But in this case I'm going to return a 1. In this case I'm returning the length of the path. If n is even, here I return Hailstone. I make my recursive call. And here, if n is even, I'm returning the path length with the input. See, here the input would be n over 2. Here the input is n over 2, and I'm adding 1 to the length. Okay, because the fact that I'm calling PL again, that I'm going into the loop again, that tells me I'm adding one more item to the one more number to the path, right? And then here this says return Hailstone 83, and this says return path PL, which is this helper function for path length, with this value, the 3n plus 1, right? But also this additional information of the length. Okay, so basically I'm copying everything that Hailstone did, but I'm adding this extra piece of information by having a helper function and then just adding the extra information in my calls in here. Okay, so let's take a look and see how that works. And then oh yeah, so what I did was I said let me try running that with path length 4 and see what that looks like. So I'm going to go into here to visualize it. So like I said, I'm not using this Hailstone 83, so I'm going to define it, but I won't ever call it any place. So that gets defined right here, Hailstone. I define path length, PL, even P. So now I have my functions defined. And now I'm going to actually execute this print path length 4. So let's go into here. So that makes us go into path length, and n is 4 at this point. So now I'm going to go into my helper function, my PL. Okay, and what happened? I have n is 4 and length is 1. Okay, so I go forward. If n is even, so n is even because it's 4, right? So I'll just return, oh, well first I got to do the test. Okay, returns true. And then I'm going to return half of n, right? Here. And notice I added 1 to length. So now I have, because I have 2 elements in the path now, right? I have 4 and I have 2, okay? So now if I'm equal to 1, no, I'm not down to 1 yet, I'm still at 2. Is it even? Yeah, 2 is even. So now I'm going to go in, I'm calling PL again, this time with n over 2 and length 3. Okay, so now I have, now my n is equal to 1. So I'm going to return, so now I'm done, right? I have a list of length 3, so I did 4, yeah, with all the, you look at the PLs here, 4, 2, and 1. So I had 3 items in my path, 3 numbers in my path. So I end up returning a 3. And see how these returns all come back, so that I get a value out of path length, and then that gets printed out right down here. Okay, so so a similar strategy could be used for getting the path height, right? So we would kind of want to do something like, instead of path length, we're doing path height. We want to get the maximum height, so let's see. If we started out with, I'm trying to remember how I did it here. I think it's safe to start with 1 because all the heights are going to be at least 1, right? So I'm going to make a helper function pH for path height. Okay, and here, so instead of So instead of trying to keep track of the length, this time since I'm doing path height, I'm going to keep track of the height. Okay, so if n equals 1, I'll just return the height, because again, if I put in hailstone 1, I would have a path with just the number 1 in it, and the highest number in that path is 1, right? So so if n equals 1, I'm going to return the height. Otherwise, I'm going to do my pH again, but now this time, I'm not keeping track of the length anymore. I'm keeping track of what's the highest value that n ever takes on. Okay, so there's this function that you can use to compare two numbers called max. Okay, so we can compare the height that I'm, the thing I'm keeping track of with n, the latest, the latest number that's being added to my path, right, is n. So we keep adding these n is every time we go through here, we add the number n to the path, basically, right? So I'm comparing then the highest height I have so far, basically, with the height that just came in here. So this is max. So I'm going to take the max of those two, or in other words, the highest value of these two. So now my pH then is going to get, in this case, it's going to get, if n is even, it's going to get n over 2 for n, and it's going to get the max of height and n for height. Okay, so it's going to call pH with those values. Otherwise, what I want to do is call pH with the 3n plus 1, right, because that's my old hailstone thing. And again, this max I'm comparing. Instead of adding 1 to the length this time, I'm keeping track of the highest value of n that I got. Okay, so now let's do max height. Max height. Okay, so let's see. So there were 3 elements in the path, 3 numbers in the path, right? For when n was 4, it was 4, 2, and 1, right? We just kept dividing because we just kept doing this one every time. We hit even p every time, so we kept dividing by 2. So there were 3 elements in the path, but the path height, the highest number in the path, is the number 4, right? It's that first number that we put in. So this should print out a 4. So let's execute this one and see. So again, we're not using hailstone here, but I just left it in there for comparison with these other functions. So I've got define path height, I define pH, I define even p. So all these are defined now. And now I'm going to go in and try to run path height with an input of 4. So let's see. So here's my n is 4. And now I'm into my helper function here. Okay, so it's the helper function that is going to keep track of, all the heights, and let's see. So n is 4, height is 1 at this point. If p is even. Okay, yes, it's even. So now what we're going to do is we're going to call pH again with the max of height and n. So now the max of height and n, the max of these two, is just the larger of these two, which is 4. Okay, 4 is greater than 1. So this is going to evaluate to 4. And this, since n is 4, this is going to evaluate to 2. So this next time we're going to be calling a copy of this pH function, and that copy is going to have n as 2, because 4 divided by 2 is 2, and height as 4, because the max of 4 and 1 is 4. So let's go down there, and there it is. Okay, so now we've made another copy of pH, and this copy has an n equal 2 and a height equal 4. Okay. So now let's see, is 2 even? Why, yes it is. So we're going to go down again, and this time we're going to make another copy of pH. See, we have another call to it. We have another copy of pH, and that's going to be, in this one we're working with right now, n is 2. 2 divided by 2 is 1. And the height we're working with right now is 4. Well, if we compare 4 and 2, 4 is the bigger number, so this is going to evaluate to 4. So we're going to pass in 2 divided by 2, we're going to pass in a 1 and a 4. Okay, so our next copy of pH is going to have n as 1 and height as 4. Let's go in and see, and there it is. Okay, so now we've made another copy. So each time we call the pH, we make another copy of pH with the new values. Okay, so at this point, oh, look at this, n is equal to 1. So we're going to have n equal 1, and we're going to return the height. So let's see what that does. Okay, so we return, you see right here it says return 4. That gets returned up to here. Okay, so notice this is just just wants to return the I'm sorry here. This just wants to return whatever got returned by the previous copy, or by the latest copy of pH. Okay, so now. So the other copy that was here of pH returned a 4, and then it was finished. So it went back, so it went away. But now we're going to return the 4 from this pH, right? And then now we've popped back up another level. So now we're back at the copy of pH that had n equal 4 and height equal 1. We're back up to that level. And we can return, since we've got a value now from the previous pH, we got a 4. Now we can return that 4. Okay, and so that's coming back here. So now we've come back to path height, right? We've executed that, and path height is going to return what pH had, which was a 4. Okay, and we're printing that, and it prints out right there. Okay, so that's the idea of how the path height business works.